All right, let's get started. So welcome to the Real Data Science USA R Meetup. My name is Szilard. I'm the host of this meetup. And I'd like to welcome especially the watch party in Chicago. So this meetup is not a new meetup. It's only new in its name. I started this meetup more than 10 years ago. It used to be the LA R meetup, and then there was another LA Data Science meetup. And I moved both of them since I relocated from California to Texas. I moved both of them, and right now they are both online, so everyone in the world can enjoy. And the new name, Real Data Science, reflects what we've been actually doing ever since the beginning. So it's always been about data science and R that most people are using in businesses, in the real world, and not just like hype, big data and AI and other of this kind of bullshit words. So there are now two meetups. One is the data science meetup, which is mostly machine learning, and the other one is the R meetup, and both of them reflect, or they are kind of like following what I've been doing in the last 10, 15 years for my work. So today, well, we are very lucky to have Gergely, who is a superstar in R, and he's going to talk about R in production. And this is really one of my favorite topics, as is really the heart of what I just called real data science. So Gergely, you probably know him. He has developed many R packages. Many of them are on CRAN. He's a regular speaker to R conferences. That's how I actually met him in, I think, 2013 at USAR. He's been working in industry at car.com and now at System One. He's been teaching R. He authored a book in R. So he's really one of the best persons in the world to talk about R in production. And today we are very lucky to hear from his experience, and he's going to summarize how he has used R in basically more than 10 years in production. So let's welcome Gergely, and I think I kind of forgot to put on this slide, but here you go now. And now, Gergely, you can take over the slide sharing.
Perfect. Thank you very much, Szilard, for the extremely kind introduction, and welcome everyone. Let me share my screen. Okay, and thanks a lot again for this opportunity. It's a great pleasure to be here and talking about this topic. Well, as you can see, I picked a rather ambitious, if not bragging title. Sorry for that. I came up with this because I've seen a lot of talks recently about how to, if even possible, to use R or even Python in production, and just wanted to somehow emphasize that it's been a thing for quite some time at least at different companies. Let me do a quick intro. I have these GitHub pages set up, and I will share some references later on if you're interested in some of the details, and listed here some related talks that I gave in the past years about using R as part of a web application, using R in the cloud, for scoring GBMs and a few other things like making secure database connections from R, doing stream processing from R in real time, also managing online campaigns, and also about the potential risks in running R on the cloud or behind service. That's not a highly discussed topic, but I think extremely important. And as a warm up, part, let me just do a quick demo just to show why it's important. And don't get me wrong, I'm a big fan of this site and I don't think there's anything bad there, but just wanted to show a quick example like what might go wrong when you are running R and in a service that's publicly available. So, oh, and probably Silarvi will have to cut this out from the recording. This is about the security part, and well, Szilard already did extremely kind introduction, so I will keep this short. Has been using R for like 15 years, developing some packages related to API integrations, and using R in production in the means of logging and so on. I've been fortunate to work at companies where working on open source packages has been important and supported. And besides that, I've been trying to be an active member of the R community and organizing meetups, conferences, and also teaching at various universities. And besides that, I have some ongoing side projects which are also relevant when it comes to using R in production. I will share some examples later. But let's start with the actual topic. So let's dive into what is production. First, let me just provide a few examples on what I think is using R in production. And I will not read this up, but summarizing, I think using R in production is using R as part of a web service in the background or running R as batch scripts, maybe to generate some reports or use R for ETL. Also using R for stream processing, which is also totally doable. And also this is pretty standard at many companies, having batch jobs, training scripts, and also using R for serving for API requests in real time. So to summarize this and defining what is production, at least in my opinion, using R in a non-interactive way. So compared to using R for ad hoc data analysis, maybe in RStudio, here we are running R without any manual intervention. So maybe using a job scheduler or using R as part of an API. Usually running R in a container, making sure that it's a reproducible, standardized environment. Really important to think about security, like encrypting what needs to be encrypted and having different safeguards so that only folks can have access different parts of your application who are supposed to access that. And also when it comes to the output of your R scripts, it's not only making sure that it's stored for a given amount of time, but also making sure that you're writing out all the information that will be useful for debugging later on. Of course, recording that in a way that it's available and setting up maybe active monitors so that you can get alerted when things go wrong. So let me show you this quick video that I think I've shared a few times previously, but this really well summarizes how it feels running in production, running R in production in some cases. So this is when you get an email from a job scheduler about an error that happened, and you start to investigate what's happening, and you realize that, okay, I made this little bug here and there, you fix it, and everyone's happy. So to be able to do this happily, you have to do some best practices so that it will not be a painful action. Showing you some examples when you schedule a job, let's say running with R script in Jenkins, Airflow, or whatever, and the only thing you see in the output is this one, subscript out of bounds, probably the most often searched term related to the R language. It's really difficult to figure out what went wrong and where in your R script. Well, here we have at least some pointers. So we know there was a function called G and F and something called the other. But if the error message is something like this one, you're clueless and it will be super difficult to figure out what happened. So I included some best practices with a lot of exclamation marks here. That's a summary of a previous talk that I've given at the Saturday LA event. If you're interested, please check that out. It will have even more exclamation marks. About my session and what I'm most recently using very heavily to make sure that my R scripts are running okay in production. One is Logger, which is an R package for logging, as you might have guessed, and the other is Boto R, which is a wrapper around the Boto free Python library to interact with AWS. While creating a new package for logging, there has been quite a few packages on CRAN related to logging. As you can see here, I try to filter for those packages. I try to write up why I decided to create a new one. Honestly, I try to contribute to already existing packages with more or less success. Also, things were just not working in the way I liked in other packages. So this is how a new package was born. Got some good feedback on Twitter and on GitHub, so decided to share this later on. Quick demo into this, you're just loading the package. You set a log level threshold if you wish. Otherwise, it will just use the default. And then you're using the log underscore commands to log things with different log levels. And you can use like the glue syntax, like f strings in Python, and a few other formatters as well. Just summarizing how this logger package is working and the life cycle of a log record. You start an R function logging somewhere. We will quickly check if the log level threshold is met. If not, then we can move on. Otherwise, the formatter function will be called so that we create a string from whatever has been passed to the function. So we could use sprintf, or we could use glue or any other string interpolation tool. Then we need to render an actual log record, which means that the message will be somehow put into a format. Like here, we have the log level timestamp and the actual message, but this could be JSON or any other format. And then you define your appender function, which will deliver the log record to a given destination, maybe to your console, maybe a standard error, maybe a file, a database table, or it could be Slack, whatever. And you can also stack these. Here you can see a real life example. This is a screenshot of one of our Jenkins jobs. And hopefully from this, you can see why this is useful. You can see when we are making a connection to a database, like which warehouse we are using in Snowflake in this case, what was the actual query that has been running, how long it took, number of rows returned, and later on some custom log messages here, like the number of filters, rows. And this script is training some time series forecasting models. You can see the number of observations, number of gaps, so missing data in that, and what kind of model has been used for that. If there's a problem from the flow of these logs, it's rather straightforward to figure out what was the problem. So this is another example, just logging in JSON as part of a web application. And you can use Logger in different packages, like I've been doing that in the DBR and the Boto R packages. From this, hopefully you can see why this is useful, like just running a SQL query in SQLite, like selecting 42. The returned data frame includes the single number as we have expected, but other than that, we also see a lot of automatically made logs for you, which will be useful when it comes to debugging. Also storing a lot of metadata about your query so that you can rerun that later on without respecifying the SQL query. This is another related helper that I found useful in the past. This is just a single helper function in the logger package. Once you add it to your server.r, then you will get an automated log of all the input changes. Let it be a dropdown, a radio box, or whatever, it will be logged automatically for you. You can also do async logging with the help of a background process. It's useful so that you are not blocking your actual application with logging, because logging might be slow if you are doing API request as part of your appender function, maybe sending data to Slack or something like that. And well, there are a bunch of other features. If you are interested, please check out this talk from the Studio conference last year. But about actual projects I've been working on, like a long time ago, 15 years ago, I've been generating tens of thousands of pages of PDFs with cross tables and ggplots and even base R graphics, and doing various things like analyzing the volume of transactions at different ATM machines, and trying to forecast the amount of money needed at different ATM locations, also signaling when the number of transactions or the amount of transactions just crazy, when like a financial crisis is coming up and banks might need to act on that. Also, some interesting metrics like the Horst exponent on stock exchanges and other crazy things like using R from a PHP script triggered from JavaScript with some custom caching, again, long time ago. Fortunately, nowadays we do not have to do these kind of things since we have the R Apache module and Plumber and all the related great tools. And also I did things with R like running the quality assurance of different universities, using OCR to identify the responses from students and processing that in an automated way and generating reports for the university. Uh, anyway, these projects, although used R in production, like in a non-interactive way, I consider Reporter.net my first real production use of R around 10 years ago. This was a startup idea that I started with a few friends back from the time when I was teaching full-time at the university, but then decided to transition to this role later on. Quick example of reporter.net, what it did: you could upload some data. It had a basic data editor. You could create reporting templates with some inputs defined, which were dynamic inputs for your reports. And this document is something like what Knitr does nowadays. It's been using a different backend called Panda, which included some extra features we needed to run this application, and was actually released 1 week after Knitr. So didn't really took off, but it has some great features for using our as part of a web service. Like, it's not only evaluating your R expressions, but also storing all the errors, warnings, the standard out, and everything about your R code chunks so that you can iterate on that in your application. Also, it rendered a nice user interface for your dynamic inputs for the template. And based on that, you could generate reports in Word document and HTML and so on. I know nowadays this is not a big thing, but it's in 2012 when Pandoc has been hardly used. It's been a really great technical challenge to work on these and been a great time. Also, it was the first time I attended UseR when I had the pleasure to meet with Szilard and presented this poster, which included a high-level overview on the infrastructure behind Reporter.net. And I will not spend a lot of time here, but you can see that there are some interesting patterns here, like R is shown here only in the bottom right corner, and there's a lot on the top of that. Like we get a request from the user and it will hit a Ruby on Rails application running behind a proxy. And this Ruby on Rails application will communicate with R, which is yet again running behind a load balancer. And there are many, many different R sessions waiting for your request. Everything is behind app air more so that your R session cannot touch on files it should not touch on, like etc password and so on. There's some automated monitoring setup, and also in the middle there are two NoSQL databases that we used, one for user management, the other one for reports, network file system, and a bunch of other things here, which was a great challenge to put together at that time. Again, I had a great time. It was a very good technical challenge. Did a lot of benchmarking, simple things like which JSON parser or serializer to use, which is feature rich and also performant. Back at that day, JSON Lite did not exist, so I had to use some other things. Also, how to encode and decode base 64 and few other related examples, like which database backend to use to store uh, our templates and reports. And this is how I got familiar with the advantages and disadvantages of different solutions. Like here you can see that Redis was super fast when it came to writing. CouchDB was like 2 times slow, but on the other hand, it created indexes in the background. So when it came to reading and filtering, it was just way, way faster. And this is how we decided to have two different NoSQL databases in this application for different purposes. So in those days, I really missed some like systematic background and training in computer science. My background is in social sciences. And you can also see this from my question from like 10 years ago that I asked on Stack Overflow, how to load data quickly into R. And let me just show you the problem. Uh, I wanted to read files written from SPSS, but I did not really care what kind of data transformations I need to make before that. I'm happy to convert to CSV or binary or data files or upload it to a database backend or whatever. I was benchmarking the different tools and found that binary data format is pretty quick, but when you want to access only a few columns, then maybe a database backend might be better. Like you can see here, it's around like 100 milliseconds. I was doing these benchmarks on a laptop back at the day, and after some time, I came up, as I described here, a rather hackish but creative way of storing data so that it will be extremely quick as part of my web application. And we can load a couple of columns of a data frame uh, very, very quickly. And as you can see here, what's happening is that I grab a data frame and iterate over every single column, write it to a single file, and just put all those files into a tar archive. And then later on, I'm loading only the required files, so the required columns, and just creating that. I mean, C binding those into a data frame or matrix. And of course, this is super, super quick. But and the benchmarks looked great. Later on, when I got familiar with the concept of columnar storage databases, I was like, I should have run. I mean, I should have read a couple of related articles instead of reinventing columnar storage in R. So that's the main takeaway from here. So when I got kind of fed up with business development challenges with my startup, as I'm a technical person, really enjoying working on technical problems and not a big fan of solving problems for actual customers and clients, I accepted a job offer, moved to Los Angeles, became a programmer there, and you can see it was a rather hands-on role. If you're not familiar with car.com, and I know kind of running out of time, so I will keep it short. We offered personalized prepaid debit cards and in various designs And we had the pleasure of having a lot of related transaction data. So we could do LTV calculations and based on that do targeted ads on different social networks with different designs. It was a really a good technical challenge and I really enjoyed working on that using a bunch of different technologies. And my actual main role was standardizing the data related processes to use R because at that point we used like Drupal scripts and Bash and Python and then all kind of other things to do, for example, ETL and reporting. For example, as you can see in this example, there's this Java script as part of an ETL job, which is just doing date format transformations, which is a one-liner in R. So it's been great refactoring all these to the same language. Some open source packages created at that time and got some experience about managing online ads using R. One is the FB Reds or FREDS package. Also, I've been working on wrapper R packages around the AWS Java SDK so that you can interact with AWS easily, which was important, for example, for the stream processing. And applications we had at that time. A quick example here, we got a real-time feed of transactions. For example, a user withdrew some money at an ATM terminal. So this information was pushed to a Kinesis stream and then our consumer application got this data in a couple hundred milliseconds. We did some lookups in a database, enriched the data, we sent that to another Kinesis stream for risk scoring, yet another R application running, which could alert some teams or act on that transaction. We could also send a real-time notification to the customers, and I was extremely happy to have an R-based service running for all the real-time notifications, sending text messages, emails, push notifications, and everything we had at that time, and just proving that R can totally do that. And actually the development time was much faster compared to what the software engineering team estimated previously. Well, after some time, despite the fact I had a really good time at car.com, I got a job offer. And at that time, I already moved back to Hungary with my family and accepted a position with a fancier title. Although, as you can see from the number of contributions, it was still rather hands-on. Well, it is still a rather hands-on role. And quick overview on System One or OpenMail, if you have not heard about this company. We are an acquisition marketing platform, which means that we are buying traffic on the internet and routing folks here and there and trying to make some arbitrage in between. Just to show you some numbers, which is, I think, interesting for data scientists so that you know why I am excited about this role. We have a lot of data coming in, a lot of volume, and you can make a huge impact with some optimization. Also, privacy awareness is important for me. So I was really happy to see like Start Page and WaterFox under our portfolio just to signal you that it's not the shady part of the internet. We can also do research, not just working on packages and scripts, squeezing some extra revenue. And we have quite a lot of open source tools published on our site, both in R and Python. We also created a nonprofit org just to have a separate organization from System One, which is managing all our open source tools. One example is the Snowflake database driver that I use to benchmark, for example, Snowflake, just to see if their marketing materials are right, and those proved to be okay. So we became a happy Snowflake user later on. But besides all the fun stuff like working on open source tools and benchmarking, of course, there's some maintenance to do as well. And I really like this analogy that I borrowed from a previous role from like 10 plus years ago when I was helping out with some sysadmin tasks for a game service. So when we were discussing what kind of infrastructure we should pick for using R in production, there were folks saying you should use EMR and just run R on it. Kubernetes is the thing, and so on. I think when it comes to using R or Python for data science and not for ETL, it can be summarized by this. You have a lot of data, of course. For those, it makes sense to have a bunch of different nodes doing the same stuff, so running things in cluster. But when it comes to running a modeling task or scoring, usually that can just run a single node, especially in AWS or GCP, you can run nodes with, let's say, 8 TB of RAM. So usually that's enough. If you're not into image processing, you can get away with a single node, and you can keep all the distributed tools for ETL, just like we used that back in the days when we had to mitigate some DDoS attacks for a game service, and we decided to put on some extremely cheap proxies in front of the application. And if someone DDoSed our service, only a few nodes died, and the majority of the users did not even realize that there was an attack. I included some screenshots from our database tables just to show you how we are monitoring jobs. Here I highlighted that we have around 4,000 separate tasks running in the data science team. These are Python or R scripts. And these are running either on the job scheduler on Jenkins, or these can be running on remote Spot instances as well. Just a second, sorry. And here I am back. Sorry, folks. So these R and Python scripts can run on the node, on the scheduling node, or on remote Spot instances. And those Spot instances are created on the fly automatically and scaled automatically and then killed in an automated way. And let me show you how we are doing that. So besides capturing this high-level data, we are also monitoring these remote jobs very closely. Like we log the amount of CPU used and memory used every 1 or 2 seconds at the Docker container level, so that we know if this application can scale to multiple CPUs and what was the maximum memory it required. And then later on, when you run a similar job, and this is a screenshot from one of our Jenkins jobs, we know the history of that R or Python script. We can know that it used 6.4 gigabyte of RAM. It could scale up to 14 CPU cores. So if we want to make sure that this runs within 4 hours, we just look up our benchmarks on the different EC2 types and pick one which is the cheapest for our goal. And in this case, we will start an R5A large instance as a Spot instance, so very, very discounted price. Start it and run the application and then kill it. Usually this is straightforward. Sometimes we have to automatically retry a few times because one instance type might not be available as a Spot instance in an AZ. So we will try that in an other AZ, or we might pick another instance type which is similarly cheap and performant. All this is handled by a single script, but it's using a lot of open source tools in the background, like the CloudPerf Python package that I highly suggest you to check out. This is doing the automated benchmarks of all the EC2 instance types and keeping track of all the Spot instance prices so that we can pick the optimal instance size for our scripts. And we are doing monitoring not only at the Docker container level, but within the Docker container, you can run various R and Python scripts. And here we are capturing what modules or packages has been loaded in that job, which is useful when it comes to updating your R and Python packages. You know actually which script is importing and using those, instead of trying to grab in your Git repository. You exactly know what's dependent on, let's see, on Boto 3. Also, within a script, we have the concept of different steps. And a step can be arbitrary code chunk, which will automatically run a snapshot for you at the end of the step. And the snapshot means that it will write all the data objects into a binary format, upload to S3. Of course, it's doing like hashing of the objects, checking if it needs to be uploaded or not to the cloud. So it's trying to minimize the overhead, but it's been super useful because you can download the snapshot at any time and debug what happened in the middle of a script. So it's been extremely useful. Of course, we are hiring, so make sure to check out if you're interested or reach out. And the last project I wanted to share, this is one of my great interests nowadays, a side project. This is a precision dosing or precision medicine web application, which means that you enter some data into the system, and I included some screenshots on that. You enter some data, and based on the data, we will provide a personalized drug dose to solve a problem. So in this case, we will pick voriconazole, we will do Bayesian adaptive dosing for a PK/PD target. You provide some patient information. Of course, this can be fetched from an EHR system. We are integrated with for example, Epic, so that you do not have to enter this data, especially when it comes to historical records. Like for this patient, let's say we know that they got an IV dose at a given amount of at a given time, later on an oral dose from the same drug. We measure two blood concentrations in the meanwhile so that we can do the personalized fitting of the algos. You provide a list of dosing regimens that you are okay administering. It will run in the cloud on cloud services, so you could run it on a mobile phone and on desktop and so on. What's interesting here is that this progress bar is using an R model in the background. So based on your inputs, we will figure out how long it might take to run the actual application, give some feedback to the user, and here you can see the results like the simulated blood concentration, the first dose, the oral dose with some different curve, and also the suggested dose on this plot with a few other parameters listed below. So this is the high-level overview of the application, but I wanted to share how R is being used in the background because this is heavily driven by R. So all our simulation methods are R templates where you define what kind of inputs you need, what drug is supported by that template, what method, if it's empiric therapy, Bayesian adaptive dosing, and so on, and the actual R code. And this platform will automatically generate the user interface for you in a HIPAA-compliant environment. And the emphasis on this when it comes to using R in production, that you need to create an environment based on R that complies with HIPAA. If you're interested in the details, this is how this service is implemented using AWS and some GCP. R is running here in the middle on these EC2 boxes. So there is a lot of services around that. It's really interesting to see how you're using R from a web browser, using authentication, making sure the user have access to different API endpoints and all the related things like some NoSQL databases and so on. If you're interested in the details, I gave a talk on this at this year's user conference. And let me just wrap up. So when you create a service which is HIPAA compliant and super clean, and there's not a lot of tech debt, and everything is nicely documented, it feels, of course, super great. On the other hand, it's rather painful. And just to show you a couple uh, things that needs to be done so that you are using R properly for such a case. I think usually common sense just works, and also things required by HIPAA and other security frameworks and privacy frameworks, that's just common sense, like having code review, that's pretty standard. Running unit test, integration test, end-to-end test, everyone's doing that nowadays, but there are some other things like having your own policies and making sure you're complying with those. Also vendor management, that's not something an R developer often does. So there's quite a lot of extra steps you need to do compared to running, for example, a Shiny application. Also, on the top of compliance, this is an application that's available in 6 languages. So we needed to translate both the front end and the back end to different languages. And the related support in R wasn't great. So we are working on a package that I hope we can open source soon so that you can very easily translate different strings. At a high level, we have around 4,000 words per language that needed to be translated, and of course needed to provide the related infrastructure so that every time you push or you try to merge to the main branch, it will be automatically tested that every single term is extracted to the translations and everything is translated to all 6 languages. Otherwise, you will not be able to merge. And I know we are very close to the end of this session. Sorry for running a bit longer. Uh, Please reach out later on if you have any questions, and I might not be able to answer that now, but if there's any that I can answer now, I'm more than happy to give it a try. Thank you, folks.
All right, thank you, Gergely. So we'll go now into Q&A, and I will actually ask the first question myself. And just to give a little bit of intro is, so I think when we are talking about real data science, what most data scientists are using when doing real world applications is as tools is either R or Python. And obviously I'm biased towards R. Notwithstanding, I think that R is the best if you are doing data visualization, if you are doing some kind of general data analysis, hackery, or if you are doing statistical modeling. And also R is not bad if you are doing machine learning, especially if you are doing, let's say, gradient boosting machines, then all the libraries are C++ or Java, and they have hooks in R and Python. So essentially, it doesn't matter if you're using R or Python. Maybe where you raise eyebrows is if you're using R for data engineering. And I know that Gergely is one of the people in the world who push this as far as possible. So you have seen many examples of these. And I know that at System One, you have team and several people. Some are using R, some are using Python, and some are using kind of both. So and I know that you are now mostly focused on data engineering. So how does this, if you can talk a little bit about how this works out in your organization. So what is R and what is Python, and who is using what, and how do you guys work together, and how these technologies work together?
Yeah, this is a great question. Not that straightforward to answer, I fear. Uh, well, I'm obviously biased towards R because that's what I've been using mostly. But honestly, I do not think that it really matters which one a team picks. But it's really important that we standardize or we try to standardize most production things to a single language, because when there's a problem, debugging and maintaining those scripts will be just much easier if everyone speaking and using the same language compared to when different solutions are implemented in random languages. So either R or Python will be great tool. Of course, depending on where the team is focusing, either R or Python might make more sense. Um, like when it comes to text processing, probably Python is stronger, but for most things when it comes to visualization and so on, and classic regression methods and so on, R is much stronger. But to answer your question, that's right. At System One, we are using both, and data scientists are free to pick either. And we have been mixing both R and Python, and most of the team members have been proficient with both, and switching from Python to R or the other way around has not been really troublesome. We also created some tools so that you can very easily integrate Python in R and the other way around. Since Reticulate, this is super easy. Like I created a couple of wrapper packages, for example, for Boto free. We can totally do that for some internal Python modules as well. And the other way around, we have a Python framework managing most of our data science workflows. Calling R from that is also super easy. Passing the data between the two languages has improved a lot. Like years ago, you had to have an interim data set like CSV and other crazy ideas. Nowadays, you can even pass data between the two in memory. So it improved a lot. And depending on what you are working on, you can either use R or Python, whichever makes sense. Uh, well, I know it's not uh, answering the question.
Yeah,
Uh,
it actually answered much more, and also it answered the next question, which was from Madeline. Is the choice to use Python versus R based on the application, or is it the data scientist preference? So I think you kind of answered
mhm.
that one. Next question is from our friend Neil.
Oh, nice.
Hi, Neil. So his question is, great talk, man. Do you have any comments on tidyverse in production?
Oh, yeah, that's also a great question, and I have a personal take on that. I'm rather biased to other packages. I'm not saying that's the way it needs to be. I uh, I think when it comes to developing packages, staying away from the pipe makes sense in the means of keeping your packages performant and also reducing the issues which might come from scoping and so on. And the same stands for using R in a non-interactive way when things might go wrong in an odd way. So honestly, for production, I'm actually sticking with data table for all the data transformations because it's super performant. I really like the syntax and never failed me. Um, on the other hand, there are really great packages from the tidyverse, and I'm really happy user of those like ggplot and lubridate and so on. But when it comes to data transformations, I have other preferences.
Yeah, I think those guys in Chicago will like your answer, and so do I. So I think last question, probably I'm from Jacob. I'm interested in the use of PHP and JavaScript for calling R for regression models prediction function, where PHP or R would call the databases in the backend and supply the data for predict based on a user request from a web page. I only know R, and I'm trying to talk with the web developers about this, where the web developers I know use PHP and JavaScript and don't know R. You
Mhm.
said in the beginning of your talk that you did similar things and that now there are more modern, better ways to do this for our applications, for web pages. Can you explain why these ways are better?
Yeah, that's also a really good question. Thank you. So, in the old days, like 15 years ago, when I integrated R in web applications, there were no easy way to call out to R from web applications. And also, creating web services from R was not straightforward at all. So, at that time, PHP was actually running R or calling R on the CLI, passing information on the command line, and then reading the data written from R. Nowadays, you can create R-based APIs, for example, using the Plumber package from RStudio, which is great. And there are some alternatives using other tools, which has some advantages. On the top of Plumber, if you would like to have parallel processes and so on. So there are really cool packages to solve that problem. I'm also a big fan of our Apache module, which has been around for like 10 years. This is an Apache module so that when you're running a web service, you can actually evaluate R inside of that, just like how you're running PHP and so on. So you have a live interpreter there. Anyway, to keep it short, if you want to integrate R in a PHP application, what I would do is that you create an R-based API, maybe using Plumber, and then the PHP developers can integrate your API via some standard web requests. Although now that I realize Neil had a nice question, I can also refer to gRPC. Neil has been working on, as part of the Mikata group, on a gRPC server and client from R. So PHP folks could also do gRPC calls to R instead of HTTP requests as well.
All right, sounds great. I think we are about up in time. So that was the last question. So thank you, Gergely, and thank you for everyone attending. Thank you, Chicago, for the watch party. And see you next time. I'm running now these two meetups, Real Data Science USA and Real Data Science USA R meetup. So the data science will touch upon topics, mostly machine learning, mostly GBMs, and the R will touch upon obviously R and mostly R in production and this kind of real world use cases. So thank you very much and see you next time.
Thank you, everyone. Bye-bye.